Konnichiwa, Yamamoto sensei. Okay, can you hear my voice clearly?
I can. Can you hear me?
Okay.
Can you hear my voice?
Yes, perfect. Okay, so maybe I would like to start this class by using bahasa Indonesia first. Sorry. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Oke, terima kasih sekali jadi mahasiswa untuk kelas teknologi beton, baik dari kelas A sampai kelas G. Kemudian saya juga mengundang untuk mahasiswa kelas teknik korosi dan katodik proteksi pada beton. Terima kasih sekali sudah bergabung on time ya. Saya berharap juga adik-adik nanti bisa menyalakan kameranya agar kelasnya bisa menjadi lebih interaktif, kemudian nanti Profesor Yamamoto juga bisa melihat wajah-wajah adik-adik semua. Oke, mungkin nanti saya akan memberikan instruksi dalam bahasa Indonesia ya, adik-adik bisa lebih paham. Jadi selama mengikuti kelas nanti saya memohon bantuan untuk mencatat ya apa-apa yang penting, kemudian adik-adik nanti bisa mengumpulkan resumenya di my class. Gitu ya untuk ini, kemudian nanti untuk presensinya saya akan berikan Google Form melalui meeting chat. Okay, so thank you so much, Yamamoto Sensei, for your time during your very busy time. You accept our invitation to give a lecture in our classes. So here we have 150 students and still ongoing. So maybe some students now try to join in this class. So this student consists of technology, concrete technology class. We have 6 classes and 1 class from corrosion engineering and cathodic protection in concrete. So actually we have a class for grade. They learn about corrosion in concrete. So I also invite them to join your lecture today. So pertama-tama mungkin saya akan perkenalkan secara singkat untuk adik-adik bahwa Profesor Daisuke Yamamoto saat ini menjadi Associate Professor di OITA National College of Technology di Jepang ya. Jadi nanti mungkin bisa berinteraksi. Saya juga berharap nanti jangan malu-malu untuk memberikan pertanyaan kepada beliau. Pertanyaannya boleh disampaikan di chat, boleh juga langsung ya. Kalau misalnya masih malu-malu, boleh juga disampaikan di chat. Pakai bahasa Indonesia juga boleh, nanti saya akan bantu translate. So Yamamoto Sensei, I also invite the student to maybe after you give the lecture, they will ask some question. So I allow them to give the question by using bahasa Indonesia, and if they need my help to translate their question, so I will translate to you. So maybe Yamamoto Sensei, I will give you the screen and time, so the time and screen is yours.
Firstly, I want to ask, this class is around 1.5 hours?
Yes, so if you want to take maybe more than 1.5 hours, it's okay.
Okay. So can I start?
Yes, please.
と待ってください。スライドショーがわかんない。
Yes, it's already on my screen.
Which screen can you see?
PPT,
For
but
presenter.
not, yeah, presenter view.
For presenter. Yes. 共有の開始で。How about now?
Yeah, okay.
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 じゃあ、Thank you, Professor Pinta, for inviting me. Today, I'd like to speak about concrete technology in Japan, according to deterioration or durability, or how to make a good concrete. Firstly, I am a Japanese, and I'm living in Kyushu Island. Here you can see the map of Japan, and now I'm living in Kyushu Island. I'm living in Kyushu Island, and used to be, you can see the photograph at Kyushu University 2020. Here you can see Pinta, Professor Pinta. We are at that time in Kyushu University and work together. Now I moved to Oita National College of Technology, and my specialty is about the concrete technology. Next, I will talk about the what Oita Prefecture is. Oita Prefecture is very famous about onsen. Do you know onsen? The hot spring, and we can enjoy hot spring, and Oita located nearby sea. So the fish, fresh fish, is also very famous. Next, I will move to today's topic. Firstly, I want to speak about why is the maintenance of concrete structure necessary? According to Japan's current situation regarding infrastructure. Firstly, I want to check the technical terms. Corrective maintenance. Corrective maintenance is major repairs are made after the structure's performance has deteriorated and damage has become severe. That is corrective maintenance. Second, preventive maintenance. Preventive maintenance is to repair in the early stage of deterioration before the structure begins to lose performance. And next is LCC. LCC is life cycle cost. The total cost of the structure, including the total cost required for each stage of such as construction, service, demolition, and removal. And next is asset management. Asset management is that LCC is considered based on the concept of managing social capital as a national asset to efficiently extend the service life of structures. This slide shows that this information is from the report from Ministry of Land, Infrastructure, Transport, and Tourism. That is the government organization in Japan. Countermeasure for aging social facilities. In Japan, the infrastructure developed during the high growth period, and that those infrastructure is expected to deteriorate in the near future at the same time. Here you can see the table. This table shows the percentage of social infrastructure that is more than 20 years old after construction. In Japan, around 40 years before, around 30 or 40 years before, most of infrastructures are constructed at almost same time. So the 50 years old 50 years old infrastructure of the number will be increased rapidly. Here you can see the 50-year-old after construction of the bridge in 2018, 25%, but 2023, 39%, and 2033 become 63%. Next shows the same condition of a bridge. Here you can this diagram shows the current state of aging social infrastructure. Example of road bridge over 2 meters. In 2018, 25% of 25% of bridge is 50-year-old, more than 50-year-old. But in 2033, 63% bridges become more than 50-year-old. So in Japan situation, most of the bridges should be repaired or maintenance. And then the important countermeasure is how to optimize LCC and asset management. LCC indicates that initial construction cost and maintenance and management cost and final disposal cost. Total cost is LCC. And then the promote shift to according to this thinking method of LCC, Japanese maintenance becomes shift to preventive maintenance. It means that if the collective maintenance method were chosen, then total cost become high. But preventive maintenance, if we choose the preventive maintenance, total cost become lower. So Japanese government have to repair a huge number of infrastructure. So the government become as a countermeasure, government start preventive maintenance method. Perhaps in Indonesia, maybe currently huge number of infrastructure are ongoing, constructed ongoing. So in your country, how to say? In your country also should pay attention to LCC, how to pay attention to optimize the LCC. Next, I will introduce you the deterioration of concrete. Crack in concrete. Cracks caused by crack in concrete can be categorized to like that. Firstly, cracks caused by external forces. And as an initial failure, cracks due to drying shrinkage, and cracks due to autogenous shrinkage, and crack due to thermal crack, cracks due to thermal crack, and cracks due to age-related deterioration. Factors. Then factors that causes structural deterioration. Type of deterioration. Number 1, initial failure. Number 2, degradation over time. And number 3, structural deformation. Deterioration. And deterioration mechanism of concrete can be categorized to those 4. First, steel corrosion due to carbonation, and steel corrosion due to salt damage, and alkali silica aggregate reaction, and fatigue failure, fatigue fracture. And types and factors of deformation. As an initial failure, firstly, honeycomb, and surface bubbles, and cold joint, and internal defect, and sand streak. Second, degradation over time, cracking, and piece exploration, and rust fluid, and efflorescence, and discoloring, and ablation. As a structural deformation, flexibility, and deformation, and vibration. First, as a initial failure can be explained like this. Firstly, bleeding affect failure, sinking crack, and plastic shrinkage cracks, and water channels. Construction conditions affect failure, honeycomb, and surface bubble, and cold joint. This figure shows the bleeding that occurs in concrete. Bleeding is a kind of segregation. Concrete with a lot bleeding, segregation of the water that is bleeding. If the if the water to cement is large, then bleeding easily occur. And unit weight of water is large, then bleeding will easily occur. And granular content in aggregate small, then bleeding will easily occur. And if the slump is large, then easily bleeding occur. So under those conditions, bleeding easily occur. So to restrain the bleeding, we have to pay attention to those contents. Second, this figure shows sinking crack. Sinking crack means that if the bleeding occurs on the concrete, the water will rise up. Instead, the surface of concrete will sink, and the water will coming up to the surface. Then water channel will be remain even after hardened concrete become hardened, and the water also gather at the bottom of steel. Then after hardened concrete, this area become a kind of void. This is sinking crack. And next, if the sinking crack or much amount of bleeding occur, then the water channel will remain even after concrete become hardened. So from this picture, can you see the water channel remains? And if the carbonation occur, then along this water channel, the CO2 easily come inside to the internal part of the concrete. This is water channel, and along this water channel, the carbonation proceeded. And this is the sinking crack from surface of the concrete. You can see the cracks along river. This is sinking crack. This also due to the much amount of bleeding. And here, this is a kind of water channel, and this also the sinking crack. Before hardened concrete, the concrete, fresh concrete become sink, and then the crack remains even after hardened concrete become hardened. And next is the plastic shrinkage crack. Plastic shrinkage, if the plastic shrinkage crack occur, the surface condition of the concrete become like this. Small cracks, small cracks will be remain on the surface of concrete. And this is honeycomb. This due to insufficient compaction during casting. Then this kind of initial defect occurs. And this is surface bubble. This also insufficient compaction during casting. And next is cold joint. The cold joint, what is the cold joint? The time interval between the lower and upper levels during the casting was too long. If the interval time is too long, this kind of cold joint will occur. At the time of casting, if the interval time is too long, then lower part of concrete start hardening. Then even the upper part of concrete casted, here the how to say, at that time already start hardening. So here the crack or this kind of crack will remain. This is cold joint. And next, internal defect. Internal defect is how to say, a kind of honeycomb or some kind of void remains inside the concrete. That is internal defect. And sand streak, lack of viscosity of the fresh concrete fit between the formwork and the concrete. Bleeding water was rising from the gap between the formwork and the concrete. Then the surface of concrete become, how to say, like this. Between the homework and the concrete, the bleeding water will rise up. So the surface of concrete, how to say, become like this. This is sand straight. Next is degradation over time. This is due to corrosion. Firstly, number one is cracking piece and piece explosion. Degradation due to degradation over time, piece of concrete will falling down. That is cracking piece explosion. And second is rust fluid. Because the steel bar already corroded, the rust fluid come up to the surface of concrete, then the concrete surface will be as like a figure. And next is efflorescence. The calcium internal part of calcium how to say, due to the crack existing crack, the calcium dissolved into water, and with water, the calcium comes to the surface of concrete. Then the surface of concrete will be like this picture. That is efflorescence. And discoloring. How to say, become dirty. Discoloring means become dirty. And absorption. This is a water channel, and the surface part of cement paste washed out. Then the aggregate the aggregate appears. This is absorption. Those are the degradation over time. Number 3, I will skip. And next, I want to explain the deterioration mechanism one by one. First is carbonation. Carbonation is a phenomenon in which atmospheric CO2 enters into concrete and causes a carbonation reaction with cement hydrate, such as CaOH2, thereby reducing the pH of the pore solution. The CO2 in atmosphere comes into concrete, and then the CaOH2 becomes CaCO3, and the alkalinity of concrete will reduce, and then the passivity film will disappear, and progress of corrosion start. Then, due to the corrosion of river, cracking and concrete sparring and decrease in load bearing capacity will occur. How to check the carbonation is that spray 1% phenolphthalein. Then if the enough alkalinity remains in concrete, the color will be red purple. But if the alkalinity already decreased, then no color changed. Then here, this no color changed area is already carbonated area. Those are the deterioration condition of RC member due to carbonation. Because of carbonation, the steel bar corroded. Then the covering concrete part sparring. This is also due to carbonation. This is also due to carbonation. This is also due to carbonation. Carbonation. If the carbonation area comes to the surface of a river, then the passivity film of river will be destroyed and then start rusting. Next is salt damage. Salt damage is a phenomena in which the presence of chloride ions causes the corrosion of steel in concrete, rusting in cracking, sparring, and cross-sectional reduction of the steel due to the expansion of volume of corrosion products. If the chloride ions penetrate concrete and comes to the surface of steel, then it destroys chloride ion destroy passivity film, and then start corrosion process, then cracking and concrete sparring and decrease in load bearing capacity. So this is a chemical reaction of corrosion of the river. Because of this mechanism, the metal Fe river will be corroded. Those pictures are the scenery of corroded RC members. Due to chloride ion, the steel bar corroded and covering concrete already sparring. Next, actual cracks due to river corrosion. Along this side, along this line, the steel bar embedded, but the steel bar already corroded. So the on the corroded area, the steel bar expands, then crack appears. You can see rust stain. Next is progress of salt damage on PC breach girder. It progresses to section loss and failure of stirrups and PC steel wire. It might be necessary to consider whether if it is necessary not only to repair but also to reconstruct the lost bearing capacity. This figure, this member already severely damaged due to salt damage. This is also salt damage. And next is alkali silica reaction. In other words, ASR. ASR, what is ASR? ASR aggregate react with alkali inside concrete, then expand the aggregate and crack occurs. That is ASR. 次を見せようか。This is a case study of ASR. Cracks in the shape of turtle shells. This is also ASR. And if the ASR a kind of chemical reaction occurs, then alkali silica gel will be formed. Inside this picture, you can see the alkali silica gel. Here you can see alkali silica gel. and this alkali silica gel will expand with water, then the crack will be occur inside concrete. And then the surface of concrete or internal part of concrete will be like this. This is ASR. This figure shows the conditions to occur ASR. If the reactive aggregate indicates a kind of volcanic rock or serious rock. This kind, if the reactive aggregate were used, and if the alkalinity of concrete is high, and if enough moisture exists inside the concrete, then ASR will be occur. Even if reactive aggregate were used and high alkalinity, no moisture, then ASR will be not occur. And even the high alkalinity and enough moisture, if the reactive aggregate will not be used, then ASR will not be occur. So those three to occur the ASR, those three should be satisfied at the same time. Then ASR will be occur. And next is fatigue fracture, a phenomena in which a material is subjected to repeated loading at a level lower than its static strength, resulting in failure. Cracks develop and propagate in the concrete due to repeated loading. Concrete and eventually the load-bearing capacity is reduced due to steel fracture. In reinforced concrete structure, this phenomena is mainly observed in RC slabs and RC beam member of road or railroad bridges. Fatigue fracture. Fatigue fracture, how to say? This is the view from bottom of slab. This is road bridge and the scenery from bottom side. If the fatigue failure occurs, then this kind of small crack will be occur. Then how to say, slab will be destroyed like that. How to say? Even small loading, less than static strength, but repeated how to say, huge number of how to say, 何回も in long term, then even small load, but for long time acting, the fatigue failure will be occur. In Japan condition, most of highway road bridge become around 50 years. So this kind of failure is detected. So so many slabs were renewed in nowadays due to fatigue failure. So up to now, I explained about the deterioration or degradation of concrete. Then I will change the topic. How to make how to make good concrete and prevent such kind of defect. I will explain how to make good concrete. What is good concrete? If with required strength and small hydration heat and economical and less initial defect and high durability and good workability and less segregation, then we can call that is concrete. And next, this diagram shows how to make a good concrete. To make good concrete, we satisfy those three. Use proper material and do proper mix design and do proper construction. Then we can make the good concrete. And we have to pay attention to durability. We have to think about durability, the mechanism of degradation. What is the durability of concrete structures? Ability to resist weathering, chemical attack, physical ablation, and other degradative actions, and to maintain the required mechanical and functional performance of the structure for a long period of time. To make a good concrete, good resistance to salt damage and chemical attack, frost damage, ablation, and ASR and carbonation is required. Then, how we can make the durable or good concrete? To make a durable concrete, reduce water to cement ratio, densification of the microstructure of concrete, and then possibility of thermal crack in case of high, if the, and then select proper materials. If the proper materials were chosen, then we have to restrain water absorption. Select proper materials. How to select proper materials? Small water absorption, and check the chloride ion and control chloride ion. How to say? When mixing concrete, and do not use reactive aggregate, and control chemical alkalinity of concrete in when mix concrete. And in construction, we have to prevent initial defect. And after casting concrete, we have to do proper curing. Then we can make durable concrete. Next, this diagram shows the relationship between water to cement ratio and strength of 28 day. If the water to cement ratio become higher, then the strength of concrete will reduce. And even if we use same materials, the water to cement ratio is smaller, then the strength of concrete will be increased. So how to say? When we design the concrete mixture, we have to pay attention the water to cement ratio, and how to say? if we should choose small water to cement ratio, then the strength of concrete will be increased. It means densification of the microstructure of concrete. はい、次です。Next. Here I show that relationship between water to cement ratio and compressive strength. Then if the x-axis to use inverse number means water to cement ratio, cement to water ratio, then the relationship between C by W and strength become linear. From this figure, from this figure, also we can know that if the water to cement ratio, if the C by W, cement to water ratio become higher, then the strength of concrete will increase. X-axis C by W is inverse number of water to cement ratio. And here, this diagram shows the relationship between C by V. V means void. Cement porosity ratio. Cement porosity ratio. If the void of cement is smaller, then the strength of concrete will increase. To make the void smaller, we have to choose the smaller water to cement ratio. Here, this green plot indicates 35% of water to cement ratio, and this pink triangle shape of a plot indicates 50% of water to cement ratio. To make a void, to reduce the void inside the concrete, we have to choose smaller water to cement ratio. Then the strength of concrete become higher. And here, this diagram shows the relationship of relationship of several conditions of curing and strength of concrete. If the concrete were cured in the air, the strength increment will be this red line. And if until 3 days inside, until 3 days immersed into water, and from three days to keep in the air, then the strength increment will be this line. And continuously wet curing were conducted, then the strength increment will be this blue line. So even same materials were used and even same mixed proportions were used, the condition of curing is different, the strength of concrete will be different also. This shows the curing condition and strength of concrete. Next shows the relationship between strength and durability. I explained that if the water to cement ratio is smaller, then strength will be higher. But not only water to cement ratio, but also other conditions will influence strength of concrete. So, and even the same water to cement ratio, same water to cement ratio was different strengths under different conditions. それから、あとは、usually high strength concrete, if the strength is high, the durability is usually high. But durability may be varied even at the same strength. So this is not equal, nearly equal, but not equal. And durability, relationship between durability and water to cement ratio. If the water to cement ratio is lower, then the durability will become better. Small water to, if the water to cement ratio is small, it means high durable concrete. 次いきます。This diagram shows that the relationship between total void volume and compressive strength. If the total volume, the void volume is smaller, it means durable concrete, and the strength become high. So this relationship indicates that the void volume of inside cement paste, then strength become high. High strength concrete have high durability. This is one case. But if the curing condition become different, the durability become different condition. In other words, here you can see N-N1 and N-CD5 and N-W28. It means that N means ordinary Portland cement were used, and those are the same. Those are here. Water to cement ratio is 65, and this gray graph shows water to cement ratio 55. These three are same concrete. These three are same concrete. But if the curing condition is different, the durability becomes different. How to say? Here, ND1 indicates that cured in air until 28. This is D1. And CD5 and CD7 cured with a wet towel until 5 or 7 days, then cured in air until 28 days. And W28 indicates that cured in water until 28 days. Even if the same concrete were used, the curing condition, if the curing condition is different, then the durability of hardened concrete also become different. If until 28 days, the cured in water indicates the most good performance. And here, BB means blast furnace slag cement. Blast furnace slag cement were used. The durability shows high durability. But even in this condition, the curing condition affects the quality of concrete. In other words, a different durability. If the if the wet curing were chosen, then the concrete become high durable. And this affects the compressive strength also. This plot means if in air cured condition, lower strength, and if the concrete cured inside water, in water, then the strength of concrete will increase. Here, if the water to cement ratio is small, strength and durability will large. However, strength does not always correlate with durability if different conditions affect. It means different curing method were used. This will be affected to the quality of concrete after hardened. で、ここはちょっと飛ばそうかな。ここは、I will skip、ここはいいか。ちょっと I will skip this. Then, next, up to now, I explained the degradation or deterioration of concrete and how to make good concrete and avoid such kind of degradation. Then I want to change the topic. When considered from the aspect of environmental process, what is required for future concrete work? In cement production of concrete materials, I mean that the production of cement. For example, ordinary Portland cement. Ordinary Portland cement were made from mainly limestone. So limestone and burn using kiln at 1,000 to 450 degrees Celsius. During this process, CO2 emitted to produce 1 ton of ordinary Portland cement. 766 kilograms of CO2 will be released. How to say? That is because thermal decomposition of main raw material, limestone, CaCO3 becomes CaO and CO2, and burn using kiln. This process uses much amount of energy, so consumption of fossil fuels. Then the total amount of CO2 emission will be 766 kilograms per ton. Per ton. So if we use the cement, it means that the cement during a process of production of product during process of producing cement, the CO2 will be emitted. So what we can do for other civil engineer to reduce CO2 emission according to construction, here you can see use active use of blended cement. For example, blast furnace slag cement and fly ash cement. And then it can reduce clinker use. Then reduction of clinker delivered CO2. And when building a new concrete structure, LCCO2, life cycle CO2 should be reduced by constructing a high quality structure and extending its service life. In general, when LCCO2 is reduced, LCC will be also reduced, but the initial cost for construction will be higher. And by maintaining and extending the service life of existing concrete structure, then the amount of new cement used will be reduced. These 3 points are important for to reduce the CO2 emission as a concrete engineer. 次いきます。で、you know SDGs, Sustainable Development Goals. If we can do these 3 items, then we can contribute into industry, innovation, and infrastructure, and sustainable cities and communities, and responsible consumption and production, and climate action. I think that is very important point. で、ここは飛ばそう。次はちょっと飛ばします。で、next, here I want to introduce the basic principles of concrete production, 6 items, by Dr. Tokujiro Yoshida. Dr. Tokujiro Yoshida is a civil engineer of Taisho and Showa periods. Born October 15, 1888. After teaching at Kyushu University, he becomes a professor at his alma mater, University of Tokyo, in 1938. He is known for his research on concrete and reinforced concrete engineering, and is considered a father of concrete engineering in Japan. Yoshida Tokujiro. He said that concrete is cement paste integrated with aggregate. And second, cement paste determines the quality of concrete. Third, the properties of cement paste are determined by the properties of the cement, the degree of chemical reaction between the cement and water, and the concentration of the cement paste. Number 4, to select a cement paste of the required quality and to mix this cement paste with the aggregate so as to obtain a workability suitable for the job. Number 5, workability suitable for the work means workability suitable for transporting, placing, and compacting concrete. Number 6, the concrete shall be mixed, transported, placed, finished, and cured in such a manner as to clearly demonstrate the properties of the concrete. And next is important point. To make good concrete, besides cement, water, and aggregate, you must add knowledge, honesty, and kindness. He said around 100 years before. That is all for my presentation. Terima kasih.
Oh, thank you so much, Yamamoto Sensei, for your very nice presentation. So, yeah, if I may summarize your lecture. So, in Yamamoto Sensei already show us about three big topics. So, the first one is about deterioration of concrete or degradation of concrete. Yamamoto Sensei already explained us about four types of degradation. So the first one is about corrosion due to carbonation or CO2, and then corrosion due to salt image, and after that alkali silica reactivity, and also basic fracture. The first topic. So untuk adik-adik mahasiswa, jadi tadi untuk yang pertama, Yamamoto Sensei sudah menjelaskan tentang jenis-jenis kerusakan pada beton dan juga mekanismenya. Jadi yang pertama tadi ada kerusakan pada beton yang disebabkan oleh korosi akibat karbonasi atau karbon dioksida, kemudian korosi pada beton yang disebabkan oleh ion klorida. Jadi salt damage itu adalah kerusakan beton akibat garam yang biasanya terjadi pada beton yang ada di lingkungan air laut gitu ya. Kemudian yang ketiga tadi kerusakannya oleh reaksi alkali silika. Jadi ada jenis kerusakan, mungkin untuk adik-adik yang ada di kelas teknik korosi sudah belajar ya, ada ASR. Kemudian yang keempat adalah fatigue fracture. Fatigue fracture itu kerusakan struktur beton yang disebabkan oleh continuous loading. Continuous loading itu adalah beban yang menerus ya, beban yang terus-menerus. Itu tadi topik yang pertama. Jadi nanti mungkin kalau yang sedang membuat ringkasan itu bisa ditambahkan kalau misalnya tadi belum paham. Kemudian yang kedua, for the second topic, yang untuk Sensei already give some tips how to make a good concrete and avoid the degradation. So from this topic, Yamamoto Sensei already show us about how to prepare a proper material, proper mix design, and proper construction. Ya, jadi di bagian ini beliau sudah menjelaskan tentang bagaimana cara membuat beton yang baik dan bisa mencegah atau menghindari kerusakan-kerusakan yang tadi sudah dipaparkan pada topik pertama, yaitu dengan menyiapkan material yang baik, kemudian yang sesuai dengan spesifikasi atau standar-standar, kemudian juga menyiapkan mix design yang oke ya, mix design-nya juga oke, sudah di trial, kemudian proper construction itu pada saat konstruksi itu dilaksanakan dengan baik ya, dengan baik. And the last topic, Yamamoto Sensei talk about the environmental aspect that we have to pay attention on concrete production. So di topik ini Yamamoto Sensei bercerita tentang aspek lingkungan yang harus kita perhatikan di dalam produksi beton. Ya, tadi disampaikan bahwa ketika memproduksi beton, khususnya bagian semennya itu kan diproduksi dengan klinker, di mana itu menghasilkan di mana itu membutuhkan energi yang besar, kemudian pada saat produksi menghasilkan emisi yang besar ya, yang besar. Terus tadi yang paling terakhir ya, ada quote, untuk membuat beton yang bagus kita tidak hanya memiliki material yang baik ya, tidak hanya mementingkan mix design yang baik, tapi kita juga harus jujur ya, harus jujur. Mungkin itu yang orang-orang jadikan prinsip di Jepang ya, sehingga mereka memiliki konstruksi yang so Yamamoto Sensei, thank you so much. I'm sorry because I have to maybe summarize to our students. I hope they will understand what you are talking about in today's lecture. So thank you so much once again. I think it's a very good chance for us to learn from you about today's topic. And now, uh, is it possible that we have some questions from our student, Yamamoto Sensei?
Of course.
Okay. Okay. So yeah, I would like to invite maybe for you if you hope to give your question directly. Jadi saya tawarkan ke adik-adik yang ingin mencoba bertanya langsung ya kepada Prof Yamamoto. Siapa tahu setelah ini nanti bisa S2 di Oita College. So Yamamoto Sensei, I offer them to give a question directly if they hope. So maybe after this, maybe they can study abroad, maybe in Japan, so they can meet you directly. Oke, mungkin ada adik-adik.
I got several questions already.
Okay. So yeah, from this message, I also can see some students already write down the question. So yeah, maybe the first question, this question is come from Daniel Agus Mahendra. So his question is about why salt water can cause corrosion in reinforced concrete.
Can I use my PPT file to explain?
Okay. Yes, please.
これいこうか。I will share. I will share. これどれをいこうか。どう言えばいいかな。I will share the PPT file. 共有の。はい。this is an example of corroded RC member. And how to say, if the chloride ion penetrate concrete and reach to river, then the chloride ion will destroy the passivity film on the surface of river. And after destroyed the passivity film, then as like that, the corrosion process will start. So if the structures, RC concrete structures are on the beach side or face to sea water, then from surface of concrete, the chloride ion generally come inside into concrete. So in marine environment, the RC concrete, RC, the RC concrete become destroyed as like that. And to avoid this kind of deterioration, we can choose several countermeasures. One is how to say to use dense concrete. Dense concrete means low water to cement ratio concrete. Then we can control, or how to say, we can reduce the penetrator speed of chloride ion inside the concrete. Then we can extend the service life of RC, even in marine environment. And next is, for example, to use the epoxy covered concrete. So if the if the river is covered by epoxy resin, then even the chloride ion reach to the position of river will be not start corroded. For first question, is it okay?
Okay, thank you so much, Yamamoto Sensei. So, yeah, this is for this. This is the answer for the first question from Daniel. Okay, and then the next question comes from Alan. Yeah, Alan asking about the method. What kind of prevention method for corrosion? Huh? Yamamoto Sensei. Keluar ya?
Sepertinya ya.
Oh. Tunggu sebentar. Oke ya, pertanyaannya lumayan banyak ini ya, tapi kita tunggu dulu. Who is Alan? Alan Septian. Alan Septian ya, dan jadi Alan ini mengirimkan pertanyaan private ya ke saya, jadi dari setelah Daniel. Ya, kita tunggu sebentar, mungkin pertanyaan itu ya. Oke ya, tadi mungkin pertanyaan ini masih kita tunggu dulu. Oke. Yamamoto Sensei.
Sorry, my computer is freezing.
Okay, yeah, okay. So, yeah, for second question, sorry, this question is come from Alan. So he asking about what kind of method to that already applied in Japan to prevent corrosion.
Sorry, pardon, sorry.
Okay. So his question is about what kind of countermeasure to prevent corrosion in concrete.
まあ、as I already mentioned, to use low water to cement ratio concrete and how to say, additionally, if the blended cement means blast furnace slag cement or fly ash cement, if those kind of blended cement were used, then the penetration speed of chloride ion will be decreased very much. So, firstly, use low water to cement ratio, and second, if possible, use the blended cement.
Okay.
Then we can reduce the we can reduce the penetration speed of chloride ion inside concrete.
Yes. Okay.
And もう一つ。
Okay.
And one more point to satisfy to set the enough cover depth of concrete. Then we can how to say,
prevent corrosion.
We can prevent corrosion.
Okay. So yeah, thank you. So maybe I will repeat in bahasa Indonesia. So untuk mencegah korosi, jadi saran dari Prof Yamamoto adalah mengurangi faktor air semen water to cement, decrease the water to cement ratio. Kemudian menggunakan blended cement. Blended cement itu adalah semen campuran, jadi tidak hanya semen normal, mungkin ditambah dengan fly ash, atau mungkin bahan tambah yang lain. Kemudian yang ketiga adalah menambah cover depth atau menambah tebal selimut beton. Jadi biasanya mungkin 3 cm bisa ditambah lagi. Okay, thank you very much for the second question. And the third question comes from Zidan. Zidan asking about ASR. Yeah, maybe ASR is quite new for us because our research is not focusing on this problem. So he asking about how to minimize this problem, because we also live in the volcanic area, because we have some active volcanic mountain here in Yogyakarta. So maybe you have a suggestion about this? Yamamoto sensei, please.
はい。to prevent ASR ということですね。to prevent ASR ね。as I mentioned in my presentation, to prevent ASR, how to say, to make occur ASR, if the reactive aggregate is used and enough high alkalinity is exist inside the concrete, and enough moisture, water is exist, then that as a chemical reaction, the ASR, alkali silicate aggregate reaction will occur. But in other words, if some one of those three is not existed inside the concrete, the other chemical reaction of ASR will be not occur. So how to say, reduce the alkalinity. If we can reduce the alkalinity of concrete, then even a reactive aggregate were used, the ASR will be not occur. Or how to say, keep low moisture condition, then ASR will be not occur. So in Japan, to restrict the ASR effect, the government decide that use low alkalinity cement. Should be less than 3 kilogram per liube, per 立方メートルって何？スクエアメーター。3 kilogram per 3 kilogram, 3 kilogram per square meter. So how to say? In Japan, in concrete construction site, we have to use low alkali type cement. Then most of ASR can be how to say, restrict. And in addition, there is a test method for aggregate if those are reactive or not reactive. One is how to say, this is very difficult to explain in short time, but famous method for testing is using chemically check the the reactivity of aggregate. And the next is make mortar specimen and to set up serious condition for ASR, and if expand or not, we usually call mortar bar method. Those two, if we check those two tests using those two testing methods, we can know that if that aggregate have reactivity or not. But even if we use reactive aggregate at low alkalinity, if we can save alkalinity of concrete using low alkalinity cement, then we can reduce the risk of ASR effect. ということですね。
はい。
Is it okay?
So, okay. So, yeah, I'm sorry because hard rain in our area in Kusente, so maybe not so good internet connection. Yeah, but okay. So I can catch what about this answer, that how to reduce the ASR damage. So the first one is use a low alkalinity cement, and then reduce the moisture, and if possible use non-reactive aggregate. So ya, jadi untuk menghindari ASR, jadi gunakan semen dengan kadar alkalinity yang rendah, kemudian moisture content itu kadar airnya dikurangi ya. Itu kemudian kita harus mengetes agregatnya, jangan sampai menggunakan agregat yang reaktif, karena kalau agregatnya reaktif nanti akan semakin menyebabkan ASR atau reaksi alkali sedikit itu akan muncul. Okay, thank you so much. We still have another question from Rafi. He asking about the do you know about the use of bacteria to in the corrosion prevention, maybe using of bacteria?
Bacteria?
Yes.
Corrosion prevention using bacteria. Corrosion due to bacteria?
No. I mean corrosion prevention by using bacteria as maybe self-healing, or self-crack healing on concrete, maybe. Do you know about this topic? Or yeah, if not, it's okay.
Sorry. Okay.
So untuk Raffi, jadi Prof Yamamoto tidak tahu ya tentang penggunaan bakteri. Sorry?
Earthquake ですか?
Earthquake? Oh.
Earthquake とかいくつか. I got some quakes by meeting.
Big intensity?
Huh?
Big intensity of earthquake?
Earthquake はでもちょっとね、あれなんだ。
Okay.
Peter さん。
はい。
Next, which question should I reply?
Okay. So maybe one last question I will choose. Yeah, because the time is very limited. Maybe this the last question from Akmal Arkan. Yeah, maybe he is very curious. How to make concrete in winter season, because we do not have winter season, so maybe our students want to know how to
Winter
make
season.
concrete. Yeah.
Winter season. はいはいはい。
Is it possible to make concrete in winter season, maybe in Japan?
Yes, yes. How to say? In Indonesia, all of you perhaps do not pay attention to that. But in northern part, how to say? If the outside temperature become less than 5 degrees or should I say 0 degree, then how to say? The mixing water become frozen. That is very problem in northern part of Japan in winter if the constructions are going on. So in such condition, we have to pay attention that the mixing water will not be frozen, or to have to keep the temperature of concrete more than 5 degrees Celsius. So in such situation, some contractor use how to say? Some contractor use hot water and heat aggregate, and then control the fresh concrete temperature around 20 degrees Celsius. And after casting, wrapping with clothes and or in some cases use steam and prevent that the temperature of concrete going down to around 5 degrees. So to keep the 20 to keep the temperature around 20 degrees Celsius. So winter season, several points we have to pay attention. If the mixing water is frozen before during hardening process, the concrete quality will be dramatically drop down. So we have to pay attention.
Yeah, okay. Thank you for maybe for mixing concrete in winter. I will translate it in Indonesia. Jadi air yang digunakan adalah air panas, kemudian agregatnya juga dipanaskan, kemudian pada saat mixing itu dilakukan di ruang tertutup dengan suhu 20 derajat ya, kemudian setelah diaduk juga press konkretnya itu selalu dijaga di dalam suhu 20 derajat. Ya, jadi perlu tempat khusus. Okay, maybe one more last question. Our student will ask you directly. So, Fuad Abdillah. Okay, please.
Thank you for the time. Hello, Prof. My name is Fuad Abdillah. As we know, Indonesia and Japan have different seasons, and Indonesia just have rain and summer, and in Japan, maybe I know 4 seasons that add spring and autumn. And my question is, are the more seasons have the more challenge or additional concrete material used for adjust the season in Japan? Thank you, Prof.
Sorry, pardon. Sorry.
Diulangi, tolong. Diulangi.
In Japan, there are 4 seasons. And
Yes.
could you tell me your question again?
Are the more
Sure.
season have a challenge or additional material concrete for adjust that season in Japan?
Just the season Japan. Okay. I understand. In winter season, as I mentioned, that we have to pay attention the temperature of concrete. The mixing water should not be frozen. That is one thing. In winter season, we have to pay attention. In summer season, how to say? The outside temperature usually too much high for hardening process of concrete. Ideally, the outside temperature is 20 degrees. That is the best condition. So best condition to for concrete hardening process according to the chemical aspect. So in summer season, we have to pay attention also. We have to pay attention about the temperature of concrete should not increase too much. So ideally around 20 degrees Celsius is best condition. But in Japan, sometime in summer season, the outside temperature become around 40 degrees. So in such condition, sometime a contractor will use low temperature water or cooling aggregate, and then they control the temperature of concrete in fresh condition. And after casting, if the sunshine directly attack to the concrete, the temperature of concrete will increase. So sometimes they use some clothes to prevent sunshine attack of sunshine directly to concrete. For season, in winter season, we have to pay attention low temperature. In summer season, we have to pay attention for high temperature. And autumn and fall, autumn and spring, that is best season for casting concrete. So we do not pay attention, and we do not need to pay attention. Is it okay?
Okay. Yeah. To add. Oke. Sudah dijawab ya sama Prof. Yamamoto. Oke, Yamamoto said, I think the time is over. So I inform you that our class will be 1.5 hours. So it means already 9 minutes more than our schedule. So yeah, I would like to thank you so much again for you during your very, very busy time. You still accept our invitation to give the lecture for the class. So yeah, maybe another chance. Yeah, we would like to invite you again, maybe for another topic. And yeah, once again, thank you so much for you. And maybe after this, we will discuss again for another chance for collaboration, I think. Yeah. So thank you so much for today's lecture, and also for all students. We are very sorry because many question cannot be answered by Professor Yamamoto because the limited time. And I think yeah, we still can discuss again maybe in another time. So once again, thank you very much for Yamamoto Sensei for today's interesting and very interesting class. And we hope for another chance. Maybe next semester we would like to invite you again for maybe same topic or another topic. So once again, thank you so much. So maybe after this, our faculty staff will send you maybe small gift to your office. I think because of today's class. Okay. Thank you very much, Yamamoto Sensei. So maybe is it possible to take photo together to all participants? So untuk adik-adik seluruh mahasiswa mohon di on-kan ya kameranya. Mungkin Mas Priya juga bisa membantu mengambilkan gambar. Ya.
その前にI'm sorry, I cannot reply all of your questions. I'm sorry. Some students ask me about earthquake. That is how to say structural mechanics. In Japan, as you know, so often earthquake attack. So how to say we have perhaps we have some knowledge to resist the earthquake, but I'm sorry, that is not my specialty. So, such kind of question, if you have some question, if you ask me directly, I will ask structural mechanism sensei っていうかなんていうかな。I will ask some professor according to structural mechanics. But I cannot reply directly.
Yeah, okay. So yeah, we could understand Yamamoto Sensei. So ya untuk para mahasiswa jika adik-adik bertanya mengenai gempa atau earthquake, nanti Profesor Yamamoto akan mengundang profesor yang memiliki ahli di bidang gempa karena bidang kita bukan di gempa, jadi kita bisa menjawab ya. Okay, so yeah, that's all for today class. Thank you so much for Professor Yamamoto. I think Mas Priyo already take a picture for all of us, and thank you so much for today's interesting class. And I hope to see you again, Yamamoto Sensei, in the next occasion. So thank you so much, and see you. So maybe from our student, we can give applause for Yamamoto Sensei by push the clap button. Okay, so yeah, thank you so much, and we hope to see you again.
Thank you.
Oke, terima kasih adik-adik mahasiswa. Jangan lupa untuk mengirim summary-nya di My Class, dan terima kasih. Mohon maaf kalau ada kesalahan. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Prof.
Arigato. Arigato, Sensei. Arigato,
Sensei.
Arigato, Profesor.
ありがとうございました。
Jibaku Tensei.
Terima kasih Pak Daisuke. Pak Daisuke, terima kasih sangat membantu saya dalam pembelajaran ini.
Ya, Ian dimit aja ya. Okay, thank you, Yamamoto Sensei.
Thank you very much. じゃあ、じゃあsee you, 三田さん。
I see you, Yamamoto Sensei. I really hope to come to Japan again because the border is already open. I and my husband are already prepared to maybe to have vacation in Fukuoka or in Tokyo. Thank you so much. Okay, thank you so
Bye.
much.
Hilang.
Info resum.
Apa sih? Nomor